Hi everybody, this is Dr. Nageswara, Assistant Professor of Physics, SRR and CVR Government Degree College at Armas, Vijayawada. Today we will discuss about Heisenberg uncertainty principle as a part of matter waves and uncertainty principle. Heisenberg uncertainty principle is much as useful to understand the basic concepts of quantum mechanics. We know that this quantum uncertainty principle is proposed by Heisenberg in 1927. It states that it is not possible simultaneously to determine the position and momentum of a particle. It means that when the position of the particle is measured accurately, the momentum measurement is less precise and vice versa. So mathematically, this can be written as delta x into delta px is greater than h by 2 pi, where delta x is the measurement of the position and delta px is the measurement of the momentum and h is the Planck's constant. This concept is to understand quantum mechanics, just like to study the position and momentum of atoms, electrons, photons, protons, neutrinos, and generally all subatomic particles in quantum mechanical analysis. It says that not all the properties of a quantum particle can be measured with unlimited accuracy. So that the principle mathematically expressed as delta x into delta px is greater than or equal to h by 2 pi. So mathematically, how can we write? The statement of this one is delta x is, we know, that is change in momentum. So that the product of the uncertainty in delta x and uncertainty in momentum, that is delta x into delta px, is greater than or equal to h by 2 pi. So the product of the uncertainty delta x in the position and the uncertainty in momentum delta px at the same instant is equal to or greater than h by 2 pi. That is called mathematical concept of Heisenberg uncertainty principle. Of course, not only Heisenberg uncertainty principle can be explained in terms of position and momentum uncertainties, and also the pair of quantities, conjugate quantities. For example, energy and time. So, in terms of energy and time, we can write this uncertainty principle as delta E into delta T is greater than or equal to h by 2 pi. Now, how can we derive this Heisenberg uncertainty principle in terms of energy and time? We will observe here. We know the kinetic energy formula is E is equal to half mv square. That is equal to p square by 2m. How it is came? Because if this we know, the general principle is kinetic energy is half mv square. It is multiplied and divided by mass of the particle m. Then m square v square. We know momentum p is equal to mv. So that p square by 2m. That is the kinetic energy of a particle E is equal to p square by 2m. When you have to take differentiation R, that is the partial part, then delta E is equal to differentiation of P square is equal to 2P dP 2P delta P by 2M. Where 2 and 2 cancel each other, then delta E is equal to P into delta P by M. But we know momentum P is equal to product of mass and velocity. That's P is equal to mv. And also velocity v is equal to dx by dt. That is a change in displacement, rate of change in displacement. So that if this p is replaced by m into dx by dt, then delta E is equal to m into dx by dt to delta p by m. Where of course m and m are cancelled each other. Then delta E is equal to dx by dt into delta t. Or if this dt can be written in left side, there is a delta E into dt is equal to delta p into dx. Of course, dt may be written as delta t and dx may be written as delta x. Then delta E into delta t is equal to delta p into delta x. But we know, according to the Heisenberg uncertainty principle, delta P into delta X is greater than or equal to h by 2 pi. So that delta E into delta T is greater than or equal to h by 2 pi. This is called Heisenberg uncertainty principle in terms of energy and time. Thank you.